Hi, everyone. Thanks for joining the webinar today about cheqd features and tooling. What we'll try and do today is to talk you through a lot of the features that we have on cheqd Network, as well as what sort of software development kits you have to go and build all of the various different aspects of decentralized ID that are backed up within the cheqd Network. If you're new to this, last time we ran a webinar on the SSI, which is self-sovereign identity, and DID, which is decentralized identifiers, a 101 on that. So if you haven't watched that already and you're new to the space of self-sovereign identity, please go have a look on that particular video recording of that last webinar. And today I'm joined by Dave and Shonak, who are both on the cheqd sort of developer team as well, who will help run through some aspects of this. So maybe just to get started, one of the tools that I want to flag up to people is the docs.cheqd.io/product website, which goes into a fair amount of detail about what are the different types of objects or different types of verified information that you can create on the cheqd network and how you can go create that. So we're going to spend some time talking about extremely low complexity options like cheqd Studio, which is our hosted SaaS service, software development kits, in which we have a lot of them. So you can choose the software development kit that you're most familiar with, or a language that you're most familiar with. And the highest complexity, which you'll probably not need for this hackathon, is direct integration with the ledger code. But maybe to get started, I will first hand off to Dave, who will talk us through some of the basics of how all of these SDKs are built, how they hook into the network, and talk you through a bit of that. Dave, over to you.
Yeah, thanks, Ankur. So you guys can see my screen, right?
Can see the screen indeed. Yep.
Okay. Yeah, so hello everyone, welcome to the Verifiable AI Hackathon introduction. So I'm going to introduce the cheqd developer ecosystems, the tools we have built so far, and what of which you can use for this hackathon. So to introduce it, I'm separating this into five layers. So we have our cheqd network, which is the blockchain infrastructure running, and we have our SDK, which is in TypeScript, and it allows you to query or write transactions on the ledger using TypeScript. All you have to do is give it a mnemonic, and it has all the functions to publish transactions.
What's a mnemonic?
Mnemonic is a key phrase which you use in crypto wallets in order to create a wallet, right? And yeah, so we have the TypeScript SDK. This is the first layer which interacts with our network. We also have our dead resolver, which was built using Go. You can take a look at this if you are planning to create the toolkits which are interacting directly with the ledger. So these two could be the references if you want to create toolkits which are directly interacting with the ledger. And coming on to the next step is TID registrar. It's if you're creating toolkits using different SDKs or different languages, then TID registrar is where it's used to publish transactions on the ledger, and without any language interface. So it's an API. You can call it using Python, or you can call it using TypeScript itself. And so there are a lot of key management. So I'll start with the introduction of SDK and API service, and then maybe we can move on to the next ones. And I'll say why an agent layer or key management layer is needed, and then what AI integration layers can do with it. Right? So to use our SDK, all you have to do is install our cheqd SDK package. So it's available in NPM. And I'm going to show a quick demo on how to use these transactions, how to use our SDK to publish a TED document. So first step is you have to initiate the SDK. So as I said, you need a mnemonic, and you have to have, so in our SDK we have the dead module and resource module. Dead module allows you to publish decentralized identifiers, and the resource module allows you to publish linked resources such as image or any JSON body which is linked to your DID. So I'm initializing with these modules and mentioning which network I want these transactions on. So this is the SDK config options which you need. I've linked this whole introduction to SDK in the reference in the slides. I'll share it to you guys. So yeah, once we initialize our SDK, the first step is we need to generate a key pair. So DID documents, DIDs are decentralized identifiers, and this identifier is basically linked to multiple. It can be linked to multiple key pairs, and that's the advantage of it. If you lose a key, the DID document may be linked to different key pairs, and you have the option to rotate your keys even though one is lost, right? So you need to generate a key. I'm generating a key pair here. It's a very simple test. And now I have to construct a DID document. I want to decide what I have to publish. I have to construct that DID. Every DID also has a corresponding, when you resolve a DID, for example here, so I'm resolving a DID using a resolver. Basically, it resolves to a document. Every identifier is linked to a document, and this document contains the list of public keys it is linked to, and the list of resources it's linked to, and some service endpoints, right? So that's the idea here. So to create a DID document, I've created the key pair. You need to mention that what type of identifier do you want in a DID, right? Should it be a UUID at the end, or you want a base 58 string? So there are two options. So I'm using UUID here, and I'm also specifying I want sorry. I'm also specifying what type of verification method I want. So DID documents have their public keys in form of verification methods, and we support three of them, which is ED255 verification method 20, verification key 2020, or there's also 2018, and we also have the option of JSON web key, right? So as our SDK is in TypeScript, you can just go ahead and then just if you want to know what this function does, just get into this, see what it does, and explore the types, and it's going to give you how to actually explore the SDK, right? So these first two tests are basically just it is not going to publish a DID. I'm just constructing the document. So if I run the test, it should create a key pair, and then it should construct a document. If I go ahead and resolve this now, it's not going to be available, right? Because it has not published to the ledger yet. So we have a resolver. Yeah, so it's not found, right? And so as the next step, I have to submit this document to the ledger. I'm moving this. So every ledger transactions have a specified fees, and you can explore this within each module. So DID module has all the functions. So it has what is the fees for create DID doc, what is the fees for update DID doc. So you can, so if you see the function, so yeah, it has some default fees. So the creation fee is higher and updates are and deactivates are lesser, right? So that's how you explore the SDK. And so let's try to publish the transaction. And once a transaction is published, I'm expecting the status code to be 0 in order to know that, be sure that this is a success, right? Yeah, you can see 3 tests are passed now. We have submitted the dead document, and if I go ahead and resolve this now this should be available. Yeah. So the DID is linked to this document, and as I said, we have chose this verification method. So there are some rules on how you should construct this and publish it. So that's why you need our SDK in order to do these things. Yeah, similarly, you can query the did doc in the code itself, and I've left you some tests which you can try it out and make it pass, right? Which is publishing a resource or publishing, adding a service endpoint. So this is a basic overview of SDK and how to use it. Now coming to did registrar, you also need to create a key pair here in order to link your DID to a public key, right? So the signature, so I'll let you know what this submit function does in the background. You basically pass in the fees, and you also pass in what is your private key here, or you could also sign it entirely outside and pass the signature instead of the key itself. And it's going to internally like encode your payload, which is going to be submitted in the ledger, and it's going to sign it using the key, and it's going to send the signatures to the ledger, and that's how it gets accepted, right? So, and I could have multiple key pairs too in a same did document. So the key management is the complex layer in the decentralized identity ecosystem. So registrar actually simplifies your SDK. So in SDK, you need to know how to call these functions or construct these things. In registrar, all you need to do is, so let's say, so registrar is basically hosted at this link, right? Yeah, so you can take a look at the Swagger page here. It allows you to create, update, or deactivate, and all the functions in SDK is available here. The only thing difference here is you just need to pass a payload here, and it's going to. So let's say for constructing a DID document, all I have to do is go to this get API and select what I need or what I want here. So these are the verification methods available. These are the identifiers formats available, my network, and I have to pass the public key in order to construct the verification method, and this is going to give me a response. Right. So that's what. So then did registrar the creation. You construct the payload, and you need to call the create API or any API here. So taking a look at the slides again. So going to did registrar. So the workflows are in a certain order. So you create your keys, which may be in a wallet or in the code like I have in that example, and you call an API, let's say create. It's going to return you a payload to sign, right? You need to, the registrar itself is not going to sign for you. It's a stateless server running, it's an API running in open source. And you can also you should run your custom did registrar by cloning the repo, and it's also an express server, basically. And this is going to give you a payload. You're going to sign it with your keys and then call the API again by submitting the signature. Right. So basically, once you submit these with your signature, it's going to do all the validations within the registrar, and then it's going to submit it to the registry. So if you're creating using the SDK itself, you have to do a lot of validations, which the SDK registrar is doing. So that's the so here to create a DID document, all I'm passing is the network I want and the payload I generated using the previous API. And the same step. Once you call the create API, you have to call it again, but instead of in the previous step, I was submitting the dead document payload. In this step, I just submit an identifier for my previous request, which is job ID, and the signing signature responses. So there are some rules in how you should, there's a schema in how you should construct these payloads, which you can take a look at the Swagger as a point from. So now you can see that as there is just one key pair, I was able to write a test here. And but if you think about it, there can be multiple keys, and you might want some to be active or some to be inactive. Or so the key management is really complex. And what if you have multiple DIDs and you need different keys for all of them, right? So that's why if our next layer is the agent wallets and key management layer. So basically, we have integrated with Credo. It's an Hyperledger Aries wallet. It's a TypeScript SDK, and we also have integrated with Veramo, which is also a TypeScript SDK. Credo allows you to create anonymous credentials, which allows you to create selective disclosure zero knowledge proofs. You can use Veramo if you just want simple JWT credentials and not worrying about selective disclosure. If your use case is not that, then you can use Veramo. It's much simpler and very less complex, right? And yeah, the third one we have integrated recently is Akapai. It's a Python API server. So it was Python, so we had to use our registrar and resolver. As both of these are API services, we were able to integrate into Akapai using the packages which we created here. Right. So these are the first four layers. Now we are moving ahead into AI integration layer. So for this simple, we have created an MCP toolkit for the Credo SDK, and that allows you to just an agent managing your wallet. So these are wallets basically, and they handle keys within. They are all the data are encrypted. The agents can never like output your private key at any cost. So they are always within the wallet. Now all the AI integration layer is doing is it's just calling functions within these SDKs using natural language or whatever the AI is possible to do. Right. Yeah, I think so. I've covered. Yeah, resolver. I'll show you. Yeah, Ankur.
Yeah, just a quick question there. So with did registrar, do I need to sign up for an account or have my own sort of wallet to be using that?
Yeah, so for did registrar, all you need is to run the code yourself, or just if it's testnet, you can just access the API using this URL. It's open source, and for testnet, you don't need anything. But if you are going to run a server yourself, you can just clone our did registrar repo, and then you're just
download the Docker image, I guess.
Yeah, and you can configure what mnemonics you want, right? So there's a testnet mnemonic and there's a mainnet mnemonic. If you set these as env variables, and you can run if you're going for mainnet, then you should run your own did registrar server.
Okay, makes sense.
Right. So I have all these references here, and just a bit, I'll show a quick demo on what resolve. So resolver can resolve a did document that I've showed you guys. But coming to resources, So let's try to resolve this one basically. Okay, this. Okay, these are, so this is a complex resource. I'll show you a simpler one. Oh yeah, I have it within the presentation itself. So you can see these images, right? So basically, these are from. Oh, I can't access the URL here. I thought this was going to be cool. Yeah, these are basically rendering from the resolver itself. Oh yeah, yeah. So basically, you have this. You're resolving this DID. It's returning a list of resources. So as I said, you can publish an image or JSON. Or resolver has and you can pass in query parameters, or so resources have unique identifiers in this format. Basically, you have did check network and the identifier. So this is the DID. For resources, you need another unique identifier, and you can access it using this path, right? And so you can access this using this URL, or you can also query using, so let's say I want a resource, and the resource name is GitHub logo. I'm just passing it here, and this returns me an image because that's what I've passed. And if I want its metadata, I want the actual resource and its metadata. So resource metadata contains these fields. It has the name, a resource as a type, and its media type, its unique ID. Yeah, so when you're resolving a DID, you have a lot of you can have a lot of resources, and the query parameters allow you to filter them or resolve the resource exactly. So these are some functions in the resolver which I wanted to point out. And yeah, I'll come to this again. So for running, I'll cover two of the agent wallets, and Saunak will cover another agent wallet which we have. So first, I think I'll show Akapai. So this is the Python server which we were talking about, and yeah, for testnet you don't need to provide anything, but if you're going for mainnet operations, you have to provide mnemonics, right? And we have Docker Compose files here. All you need is to do some run a bash script, or you can do Docker Compose up. And what this is going, I'm running a test here so that it can publish some dates or show some resources for you to have examples, right? Yeah, so this repository, I've also linked it here. So it's within Akapai plugins. So this is also under Open Wallet Foundation. Yeah, so within cheqd, we have the documentation on what APIs are available, and this was as this is also Aries agent. It also allows you to create zero knowledge proofs, things like that. Yeah, not going to into depth. Yeah, while it's building, I can just go ahead and talk about this slide. Yeah, I think for hackathon ideas, so these are some ideas which will be useful for cheqd, and would be a great demo for the win as well. So that you can create new MCP toolkits which can be very useful for cheqd, or you can integrate with other toolkits which are available in the model context protocol. So there are so many example servers for, let's say, GitHub, or there's also Slack, Google Maps. So there are some creative tools already which can be integrated with an example toolkit which we have to create some use cases, or you could create a new toolkit or use case workflow with selective disclosure, multi-agents, or MCP clients other than text. So currently we are going to show a demo using Cloud Desktop, but there are already so many clients available. It would be cool to have a demo with a different innovative one.
Yeah, quick question. I know you run on Linux, and I assume that some other people might also be running Linux, Windows, Mac systems. Did you find a desktop client that works with MCP on Linux?
Yeah. So there is a repository. So if you just Google Cloud Desktop Linux, it's going to throw this one. But it's not the official release, but it is possible to run Cloud Desktop, or there's also an option to run. So if you go through the tutorials in Model Context Protocol, you have your tutorial to create your own client, and this basically you can create your client in any language. These four available languages, sorry, and you can run a CLI, and even this is going to work. But I've tested this, and this should work too, right? And yeah, that answers your question, Ankur.
Yes, it does. It does. Okay. Well, do we switch over to showing the demo for MCP now? Is that over to
Yeah,
Shonak?
yeah. Just 1 second. So I've spun up Akapai, and you can see that it has been pumping some text into it. So basically, it is issuing credential from one to an issuer to an holder. So there are two agents running. Sanak, do you remember the other port? It is 3002, right? No. Yeah, okay.
Maybe
You
change
can
to
check.
4001.
Oh, it's 3000, sorry.
Okay, yeah.
Oh, yeah, it's 4001. Okay, so we have issuer and holder, and basically the issuer is in the tests. You can go through the test file to within integration, within tests. You can see we have separated into different cases here as well. So this will tell you. So this is basically the same. The flow should be same in Credo, Akapai, and Veramo, basically to issue credentials. Or so let's go ahead and see. This should have created a schema in the issuer wallet. So I'm going ahead and trying it out. So it has created DIDs and schema IDs from the tests. And basically, it's going to issue a credential which complies with that schema. And yeah, so this was a very simple schema, which is saying that it has two attributes, the name and the version. Yeah, so this also has a Swagger and a complete documentation section. If you want to play around with selector disclosure proofs in Python, then Akapai is the way to go. Yeah, I think we can move to Sarnak to show a quick MCP demo in Cloud Desktop.
Okay, thank you. Let me share my screen. Right, so that's my Cloud Desktop. And I've already integrated it with the MCP toolkit that we have prepared. Dave has shared the links in that summary. And yeah, I'm just starting a new conversation. It's nothing. So we can ask like, can you, because I have already integrated it, we can start asking some questions. It's just for a demo. I mean, not always ask the same questions, but yeah, so it can. So I can start with did resolution first. And let's see what it happens. Yeah, and for Claude, it will ask for this kind of prompt user, yeah, like a yes, no. So I'll allow this because it's running a local function. So it asks for that permission to run that function. So it has resolved the did successfully, and it also verifies this. I can also create a did. And again, because it's a different function, it will ask for permission. Yeah, so that did has also been created. You can see, yeah, it will prints the JSON response in this format, as well as if you want to validate how it has actually responded, you can see it here. And then I can like similar to the Akapai schema that Dave just showed. Also, the capabilities on the current toolkit is creating a schema. So we'll see. Yeah, so it understood my instruction, and it's also again a different function, and it is sent. You can see that this is the request that is being sent, and we are using Credo as the SDK layer, and that request would go to Credo server, and then it will give the response. Can also create a credential definition using the schema. So I've not given any parameters, so hopefully it will take, yeah, it will take the default parameters, and it did. So there is now, if you see that these are the default parameters, like the tag is called default and the revocation is false. Yeah, so it also created this credentials correctly. The issue credential is not yet there, but we can still create a connection, which will need two agents. If you want to successfully demo that, you will need two agent or a wallet where you can scan the API, the connection URL that has been generated. For holder, say, I mean, we don't have anything holder yet, but we can always say this information. So this is, it's, yeah, trying to create a connection URL. Connection URL. It will also print the QR code. That's yeah, I guess, yeah, it printed it. That's the PNG version of the QR code, and but actual connection URL is this. So if you see, it is localhost, because I have not given any specific. It assumes that this is the current location of the. That's the default configuration with this. So yeah, so if someone is going to expand on this, the new demo would be, for example, you can scan this QR code and establish the connection, and then issue the connection, issue credentials, and then go on presenting credential as well. So this is the way, like in Dave's diagram, like the final, which is the AI agent view. So the AI agent in turn is talking to the SDK, published SDK, which is Credo in this instance, and then Credo itself talks to the cheqd network via, of course, the cheqd SDK and all the other tools that it supports. Yeah, that's pretty much. Any questions or anything?
No, I think that is super exciting to look at, and I'm sure it will be very, very useful for a lot of the people to run through. I just wanted to take over the screen share just again for a second to maybe summarize and talk people through places where they can continue looking at this and exploring. I'm sure the overview has been super helpful. So like I said at the top of the call, looking at docs.cheqd.io/product is it's a great resource for you to go check out. One of the more interesting things it has is a choosing the right SDK page. So we've obviously run through a couple of different options that we've mentioned, like the registrar that is built on our SDK, Akapai, Credo, etc., etc. So if you want to understand the technical differences between what sort of standards do each of these SDKs support, we've got a helpful page that goes and demonstrates all of that. And if you are signing up for cheqd Studio, you can get started with a trial account. But if you reach out to us on our Discord channel, we'll be happy to give you discount codes that you can use for this particular product if you're past the trial period. Dave, Shonak, is there anything else that you guys want to share? If not,
No, that's pretty much.
No, thanks for tuning in. And this will be recorded and uploaded to be available for replay. And yeah, happy hacking. Thanks, guys. Thanks for the demos.
Cool.
Bye.